Space is full of rules. Gravity binds worlds in orbit. Heat strips planets too close to their stars. Chemistry decides what skies are made of. But every now and then, the universe throws the rulebook out the airlock. These are the rebel worlds, planets that shouldn't exist, yet do. They defy the laws of physics as we know them, survive in places that should destroy them, and whisper the possibility that life or something stranger might be out there. Tonight, we travel light years from home to meet 3 of these renegades. Phoenix, a planet that refuses to die. K218b, an alien ocean that may hide life. Toy 1231b, a pastel world with skies that are vanishing into space. Strap in, this is not the solar system, you know. The first candidate, Phoenix, a planet that refuses to die. In the silent darkness of space, there is a world locked in a deadly embrace with its dying star. Astronomers call it TIC 3651U2760b, but to those who study it, the planet has earned a far more dramatic name, Phoenix. Like the mythical bird rising from the ashes, Phoenix survives where no world should. Its home star is no gentle yellow sun. It is a red giant, a swollen, aging star that has expanded to many times its original size. In our cosmic future, our sun will meet the same fate, engulfing Mercury and Venus, and perhaps even Earth. Red giants are merciless. They bombard nearby planets with intense heat and radiation, stripping atmospheres bare in a matter of millions of years. Most worlds this close are reduced to scorched rock. But Phoenix, it orbits a mere 1/6 the distance Mercury orbits the Sun, racing around its star in just 4.2 Earth days. And still, it breathes. Not literally, of course, but Phoenix possesses something remarkable, an enormous puffy atmosphere. Scientists estimate it is 60 times less dense than any hot Neptune we've ever seen. Imagine a gas-filled balloon the size of Neptune floating in a furnace, somehow refusing to pop. The puzzle has baffled researchers. How can a planet so close to such a hostile star keep its atmosphere? Radiation this strong should have boiled away its gases long ago. One theory suggests Phoenix may have once been even larger, losing much of its outer layers, but holding on to a core of lighter gases like hydrogen and helium. Another idea is that Phoenix might be replenishing its atmosphere through geological activity, though this is harder to confirm without direct sampling. Whatever the reason, its survival is temporary. Phoenix's orbit is unstable within the next 100 million years. It will spiral inward and be consumed entirely by its star's fiery embrace. In cosmic terms, that's a blink of an eye. Right now, we are catching it in its final act, like watching the last leaf cling to a tree in the heart of winter. The discovery of Phoenix isn't just a curiosity, it's a warning. Our sun will one day swell into a red giant too, and scientists are eager to know whether planets like Earth can survive in any form. Phoenix proves survival is possible, but it also shows the clock is always ticking. If Earth were somehow to cling to an atmosphere during the sun's death throes, it would be a fleeting reprieve before the inevitable. So picture it, a star glowing blood red, devouring the night, vaporizing its children one by one. And there, defiant, floats Phoenix, its swollen skies shimmering in the light of the dying sun. It cannot win. It cannot last. But for now, it survives, and that makes it one of the most miraculous worlds in the universe. K218b, the alien ocean, Enigma 124 light-years away, in the constellation Leo, orbits a world that has astronomers leaning forward in their chairs. Its name is K218b, and it's not just another dot in the night sky. It might be the closest thing we've ever found to an alien home. K218b belongs to a rare class of planets called Hycean worlds, a blend of hydrogen and ocean. Imagine a super-Earth or mini-Neptune with a vast ocean covering its entire surface, all sealed beneath a thick, hydrogen-rich atmosphere. It's bigger than our planet, about 2.6 times Earth's radius, and it orbits in its star's habitable zone, the cosmic sweet spot where temperatures could allow liquid water to exist. That's when the story takes a turn from intriguing to electrifying. In 2023, NASA's James Webb Space Telescope, JWST, pointed its mirrors at K218b and found something unexpected, a faint chemical signature of dimethyl sulfide, DMS. On Earth, DMS is produced almost entirely by life, mainly by microscopic phytoplankton floating in our oceans. The connection was tantalizing. Could alien oceans on K2-18b be teeming with life, exhaling chemical traces into space? The headlines practically wrote themselves. Have we found life beyond Earth? But science is never that simple. Within months, a storm of skepticism rolled in. Researchers from Oxford and other institutions argued that JWST's data might be too limited to make such a claim. The signal could have been from dimethyl disulfide, DMDS, or even other gases entirely compounds that could form without any biology involved. Smithsonian Magazine, University of Cambridge. Others pointed out that hazy atmospheres and clouds could distort readings, creating false positives. This scientific tug-of-war has turned K2-18b into a stage for one of astronomy's most thrilling debates. On one side, optimists see a glowing blue-green orb with 200-kilometer-deep oceans and microbial life drifting beneath hydrogen skies. On the other, skeptics warn against wishful thinking, reminding us that nature often produces illusions more exotic than the truth. Still, whether DMS is real or not, K2-18b is a treasure trove for science. Its atmosphere contains methane and carbon dioxide, both detected by JWST. These gases hint at active chemistry and possibly even geological cycles, much like Earth's carbon cycle. And because its star, a red dwarf, is smaller and cooler than our Sun, K2-18b's temperate zone lasts far longer, giving any potential life more time to evolve. So, we're left staring at two possibilities. In one, K2-18b is home to alien plankton, quietly thriving beneath alien seas, their chemical whispers drifting across light years to reach us. In the other, it's a lifeless but fascinating world, tricking our instruments with the complex dance of chemistry and physics. Either way, K2-18b holds us captive, not just because of what it might be, but because of what it forces us to ask. When the next hint of life appears in the darkness, will we be ready to believe it? TOI 1231b, the stealthy sub-Neptune far beyond the reach of our spacecraft, in a quiet corner of the Milky Way, drifts a planet that seems almost shy. It doesn't blaze with volcanic fury or boast colossal storms. Instead, TOI 1231b keeps to itself, cool, calm, and mysterious. Roughly the size of Neptune, TOI 1231b orbits a small red dwarf star about 90 light-years from Earth. Its temperature, by cosmic standards, is surprisingly mild, around 60 degrees. That might sound hot to us, but in the exoplanet world, it's practically refreshing. Many Neptune-sized planets discovered so far are hot Neptunes baked by fierce starlight, but TOI 1231b is a temperate sub-Neptune, placing it in a rare and valuable category for astronomers. What makes this planet so fascinating isn't just its temperature, it's what's happening above its skies. TOI 1231b is slowly leaking hydrogen into space, like a faint breath escaping into the void. This process, called atmospheric escape, happens when a planet's gravity can no longer hold on to its lighter gases. Usually, intense heat or solar wind strips them away quickly. But here's the twist. TOI 1231b is losing its atmosphere in slow motion. Scientists are intrigued because understanding why some planets lose their atmospheres rapidly, while others hold on to them for billions of years, could unlock secrets about planetary evolution, including Earth's own history. On our planet, a protective magnetic field and the right distance from the Sun helped keep our atmosphere intact, creating conditions for life. On Mars, the loss of its atmosphere turned it from a potentially habitable world into a frozen desert. TOI 1231b offers a living laboratory for these questions. Its orbit and the tilt of its star make it perfect for observation. When it passes in front of its star from our perspective, starlight filters through its atmosphere, carrying spectral fingerprints of the gases within. Instruments like the Hubble Space Telescope and the upcoming James Webb Space Telescope can read these fingerprints, potentially revealing not just hydrogen, but water vapor, methane, or carbon dioxide. And then there's the poetry of the place. Astronomers imagine pastel skies, soft pinks, muted purples shaped by the scattering of light in its hydrogen haze. In some models, exotic gemstone rain could fall. Crystals of corundum, the mineral behind sapphires and rubies, forming in the upper atmosphere before sinking like glittering snow. Whether that's real or not, the image is irresistible. Yet the planet keeps its deeper truths hidden. Is its slow leak a sign of an ancient world nearing the end of its atmospheric life? Or is it a stable system where gas loss is balanced by replenishment from volcanic outgassing or deep-sea vents? We don't know. For now, Toei 2131b remains what astronomers call a stealth world, not because it hides from detection, but because it reveals just enough to keep us guessing. Somewhere out there, under pale alien skies, its atmosphere continues to drift into the cosmos, a quiet signal from a planet that refuses to tell us everything. What the rebels teach us: Phoenix, K2-18b, TOI 1231b, three worlds with three defiant stories. One cheats death against a red giant's glare, one whispers a possible signal of alien biology. One drifts under pastel skies, bleeding into space. They remind us of two things. The universe is far stranger than our textbooks suggest, and we've only just begun to explore it. Somewhere out there, other rebel worlds are waiting, planets that will challenge our science, spark our imagination, and maybe, one day, answer humanity's oldest question: are we alone? Until then, we keep listening, watching, and wondering, because the rebels are still out there. This was all for this video. If you enjoyed the video, be sure to leave a like, comment your thoughts regarding these exoplanets, and make sure to subscribe for more space-related content like this.